Some more problems from the mean value theorem worksheet. This is number 9. F of x equals x to the 1/3 on this closed interval, -1 to 3. And it's continuous on -1 to 3. But if we look at the derivative, f prime of x, that equals 1/3 x. And if we subtract 1, that's going to be x to the minus 2/3, which is the same thing as 1 over 3 times x to the 2/3. And at x equals 0, that's going to be undefined, and 0 is in the open interval. So we would say that f of x is not differentiable on the open interval -1, 3, because 0 is definitely in there. Therefore, the mean value theorem does not apply. Okay? So, it's not differentiable on the open interval, -1 to 3, because at x equals 0, it's undefined. The derivative is undefined. So we have 0 in the denominator. So therefore, the mean value theorem does not apply. Okay. Alrighty. And then number 10. Now this looks almost, might be the same idea, except we're looking at 0 here as an endpoint, and we may get away with it. So first of all, we look at this. This is a little cuspy form. It's an exponential there, but it's x to the, it's not exponential because we don't have a variable as an exponent. We have just a function here. Okay, but this is the one that looks kind of, it's a cusp. And we can check it because when x is 0, what's 0 to the 2/3? 0. So f of x, we could say f of x is continuous on the closed interval 0 to 1. And let's check the derivative. So what's f prime of x? F prime of x is, again, 2/3 x to the, and if I subtract 1, 2/3 minus 3/3 is -1/3, which is the same thing as 2/3, or 2 over 3 times x to the 1/3. So we have a problem at 0, but that's the only place. But 0 is not in the open interval because it just has to be differentiable on the open interval. So we could say that f of x is differentiable on the open interval 0 to 1. It's not differentiable in the closed interval, but the mean value theorem, it just has to be differentiable on the open interval. It's got to be CC2. Differentiable in the open interval. So therefore, by the mean value theorem, and then you go back and kind of put this into the other problems, and I didn't really state that because it's probably a little bit better to write this. Let's say therefore. So therefore, by the mean value theorem, there exists some c that belongs to this open interval 0, 1, such that f prime of c equals f of b minus f of a all over b minus a, and please write it down every time. And my a and b are these endpoints, a and b. All right. What's f prime of c? Well, that's going to be this guy over here. So 2 over 3 times c to the 1/3. That's that, and that's going to equal, and what's f of 1? Well, that's just going to be 1. And then what's f of 0? Well, that's just going to be 0. That's nice. all over 1 minus 0. So now we have 2 over 3 c to the 1/3 equals 1. And if we multiply both sides by this, we have, or 3c to the 1/3, we have 2 equals 3c to the 1/3. And if I divide both sides by 3, I've got 2 over 3 equals, 2 over 3 equals c to the 1/3. And if I raise each power, or each side of the cube, we could do that because if you think about it, the cube root is a one-to-one function, isn't it? So if you cube the left and you cube the right, if the cube roots are the same, the cubes would be the same. And that's going to be 8. 2 cubed is 8, 3 cubed is 27. And this is going to be c to the first power, just c. 8 over 27. Now does 8 over 27, double check it, belong to that? It should, because it's guaranteed by the mean value theorem. Does it belong to the open interval 0, 1? Yes, it's a fraction, but it's between 0 and 1. So therefore, c equals 8 over 27. Just double check it. All right? So that's pretty much the nuts and bolts of number 10. And when you do these, look for detail. Make sure you write these details in. Some of you want to take shortcuts. You know, you need to write so we can see all this stuff. And then the more you write, the better you are going to be acquainted with the mean value theorem. It's very important. So the more you write, the more you learn.